Hi everybody, I'm Dr. Biomed. Welcome to the Biomed Cafe channel. In this channel, complex biological and medical contents are presented in a simple, classified, and summarized form. Also, I have designed a quiz game for you. At the end of the video, I will explain the interesting quiz game. The topic of this video is active transport in the cell membrane. Please subscribe to this channel, and if you like the contents of this video, please like it. Active transport. It requires the use of the cell energy, usually in the form of ATP. It moves the substance against its concentration gradient from an area of low concentration to a high concentration. It can move small molecular weight materials such as ions and large molecules. This movement is with the help of carrier proteins or pumps. Some examples of active transport are movement of calcium ions out of cardiac muscle cells, movement of amino acids across the intestinal lining in the human gut, and secretion of proteins such as enzymes, peptides, hormones, and antibodies from different cells. Now I want to compare active transport with passive transport. I recommend you watch one of my videos about passive transport in the cell membrane. You see it addressed at top of this page. Okay, there are some differences between active transport with passive transport. 1. Active transport uses cellular energy, but passive transport doesn't use cellular energy. Active transport is called uphill, but passive transport is called downhill. Active transport moves small ions and large molecules, but passive transport moves small ions and water. 4. Active transport moves from an area of low concentration to a high concentration, but passive transport moves from an area of high concentration to a low concentration. And 5. Active transport is done with help of carrier proteins or pumps, but passive transport can be done with help of channel proteins or carrier proteins. Electrochemical gradient. I want to explain three things for you. Concentration gradient is different concentrations of a substance across the cell membrane. Electrical gradient is the difference of charge across the cell membrane, and electrochemical gradient is concentration gradient plus electrical gradient. The inside of cells is electrically negative concerning the extracellular fluid surrounding them. At the same time, cells have a lower concentration of sodium than the extracellular fluid. Therefore, both concentration gradient and electrical gradient tend to drive sodium into the cells. Conversely, cells have a higher concentration of potassium than extracellular fluid. Therefore, concentration gradient tends to drive potassium out of the cell, and electrical gradient tends to drive potassium inside the cell. Active transport is divided into two subgroups. primary active transport and secondary active transport. Primary active transport. It's directly dependent on ATP and uses ATP. The involved proteins are carrier proteins or pumps. One example of primary active transport is sodium-potassium pump that moves sodium out of the cells and potassium into the cells. Secondary active transport. It doesn't directly require ATP. It uses electrochemical gradients established by primary active transport. It's also known as co-transport or coupled transport. Coupled transport is divided into two subgroups. Symport. In symport, substances move in the same directions. One example of symport is movement of one glucose or galactose into the cell to transport two sodium ions into the cell. And antiport. In antiport, substances move into the opposite directions. One example of antiport is movement of three sodium ions into the cell to transport one calcium ion out. I will explain about carrier proteins in the next video. Thank you for watching. Now it's time for the quiz game. I have put the link to the quiz game in the description of this video. Download it for free and enjoy it. Please give me a comment about the quiz game. In the next video, I will talk about carrier proteins in a simple, classified, and summarized form. Until the next video, bye!